In this video, we're going to examine the 5.4.5.5 review worksheet. Primarily, this video will deal with the front page, the double angle theorem and the half angle theorems for sine, cosine, tangent. Now, the first set of problems we're dealing with deal with the double angle theorem. We're asked to find the sine of 2 theta, the cosine of 2 theta, and the tangent of 2 theta. What we're given is information of a right triangle and its location. So for the first problem, we're told the cosine of an angle is 2/7, and that particular angle is located in quadrant 1. So what I'm going to do is draw quadrant 1, and I'm going to draw the angle in it with the right triangle. So here's theta, and I'm going to use the information. I'm told my adjacent side is 2 and my hypotenuse is 7 by being given that the cosine of theta is 2/7. So what I'm going to do is use my Pythagorean theorem, a squared plus b squared equals c squared. And I see that a squared plus 2 squared equals 7 squared. And what this is going to do is it's going to allow me to find my opposite side. So as I go through the Pythagorean theorem, I get a is the square root of 45, but we all know we need to simplify our radicals. So this is 9 and 5. So the square root of 9 is 3, 5 I can't break down anymore, so then I have my opposite side. I have 3 square root of 5. Now the whole purpose here is I now have everything in my right triangle. I know my adjacent side, I know my opposite side, and I know my hypotenuse. And what I'm going to do is I'm going to use that information just to find the regular trig ratios. And notice I say the phrase regular trig ratios, because what I'm going to do is I am going to find the sine of theta, I'm going to find the cosine of that angle, and I'm going to find the tangent of that angle. And I need you to be careful because those are not the same things as what the problem is asking. The problem is asking for 2 theta. I'm just finding theta. Cosine of 2 theta, same thing, I'm just finding theta. I'm doing this step right here to help us with the formulas that we're going to be using. So if I look at my right triangle, my opposite side is 3 square root of 5, and my hypotenuse is 7. Now cosine of theta was given to us as 2/7. Tangent of theta is 3 square root of 5 over my adjacent, which is 2. These 3 trig ratios are going to be used when going to our formulas. And let's just start there. Let's see how we're going to use that. Let's first deal with finding, we'll do the sine of 2 theta. The formula for the sine of 2 theta is twice sine of theta cosine of theta. So all I'm doing is plugging in the information I found above. I'm going to do twice the sine of theta, which we found to be 3 square root of 5 over 7, times the cosine of theta, which was given to us as 2/7. And now it's a simple order of operations. I'm going to multiply all my coefficients, so 2 times 3 times 2 is going to be 12. So I have 12 square root of 5, and in the denominators you're going to have 7 and 7, so 7 times 7 is 49. And so that is the sine of 2 theta. It's 12 square root of 5 over 49. And that's it. So the reason why we take the time with our right triangle to find all the trig ratios is it makes this formula pretty easy to do. There's nothing too complicated with sine of 2 theta once you get all the values. And so we can kind of do the same thing with our cosine. Now cosine of 2 theta, there are 3 different formulas. You have cosine squared of theta minus sine squared of theta. You have 1 minus 2 sine squared of theta. You have 2 cosine squared of theta minus 1. Now, it doesn't matter which one you use. You can use the first one, the second one, or you can use the third one. It's your choice. Now, how do you know which one to use? Well, notice the formulas deal with cosine and sine, and so I do the trig ratios of the right triangle above because it allows me to see which of these are the easiest fractions to work with. Well, right away I see 2/7 is really easy to work with. It's easy to multiply, it's easy to square, no complications. So something tells me I might want to use that formula. All it deals with is cosine, and that's an easy fraction. Now, what I'm really going to do is I'll do two of them. Because I like the first formula, cosine squared theta minus sine squared theta, I will do that one. And I'll check my answer just by doing the second one as well. Sorry, the third one as well, just to make sure that we are fine. So cosine squared of theta minus sine squared of theta. Let's slide this out of the way, shrink it down, and come back to it. And what we have here is cosine 2 theta equals, in this case, it would be 2/7 squared minus sine squared of theta, which in this case would be 3 square root of 5 over 7. Still not hard math in this case, if I look at it, because I'm squaring 2/7, which is 4 over 49, and squaring the numerator here is the more complicated one. Denominator is not bad, 7 squared is fine, but to square the numerator, you just square the top, so 3 squared, and you square the next term. Radical 5 squared is just 5. So I get 45. And now I just do basic math. Subtract two fractions with the common denominator. So 4 minus 45 is negative 41 over 49. Now that is my answer. Cosine of 2 theta is negative 41 over 49. That's if I used the first formula for cosine of 2 theta. What if I check my answer by using the second one? And the reason is, like I said, I wanted to use the second one originally is because that is the easier fraction there, and I only have to use it, and it was given to me. So if you think about it, this cosine of 2 theta, cosine was given to me. I had no work. So in order to use this formula, technically I didn't need the special right triangle for cosine of 2 theta. So order of operations tells us what we're going to do is we will square first, so 4 over 49, then we would multiply by 2. So 8 over 49, then we subtract the 1, which, by the way, will give me the same exact thing. It will give me negative 41 over 49. So we know we are correct with our answer, which is good. So I don't care which formula you use. It's really which one you're more comfortable with, which one you understand the most when it comes to the cosine of theta. The last one that we have is the tangent of 2 theta. Now this formula, it's not complicated, it's just a lot of work. You have twice tangent of theta over 1 minus tangent squared of theta. Again, we found tangent of theta. It's not going to be a lot of work besides plugging in and doing some arithmetic. So tangent of 2 theta is twice 3 square root of 5 over 2. The bottom we have 1 minus tangent squared of theta. So 1 minus 3 square root of 5 over 2 squared. And we're going to have to just do a lot of simplifying with the numbers, a lot of just arithmetic with numbers. Not complicated, I would say. It's mainly just the word tedious you would go through. 2 times 3 is 6, so I get 6 square root of 5 over 2. Now, I know I could simplify that. I'm going to leave it like that for a moment to kind of show you something. On the bottom, and I'm just going to do the work below, we have 1 minus, remember, you square the 3, and you square the radical. So that would be 9 times 5, which is going to be 45, over on the bottom, 2 squared is 4. So 1 minus 45 over 4 is negative 41 over 4. When you have a fraction divided by a fraction, what you want to do is you want to flip and multiply. So I can do 6 square root of 5 over 2 times 4 over negative 41. And as you simplify, 2 can cancel out a 2 here. And what I'm going to end up with for my answer is that the tangent of 2 theta is 12 square root of 5 over, now it's negative 41, but the negative always goes to the top. And that is my final answer. Now this is the full-blown tangent of 2 theta formula. It's just a lot of work when it comes to the fractions. You want to make sure you combine them. You want to make sure you have the right denominator. You multiply. It's not complicated. Like I said, the word I would use is it's tedious. But that's why I really don't use this formula unless I'm asked to find tangent of 2 theta, particularly with no other information. The formula I like to use, and I'm going to use it in the next problem, and I kind of want to show it here, is that the tangent of 2 theta, it's very similar, just tangent. We know tangent is sine over cosine. So it's the sine of 2 theta over the cosine of 2 theta. Because take a look. You have 12 square root of 5 over 49. You have negative 41 for cosine over 49. When you flip and multiply, these would cancel out and you actually get this same answer. I like to use this formula if I found cosine and sine of 2 theta already. That's when I like to use it. It makes it a lot easier. I already did all the work. I don't have to keep on going and doing more work. It's kind of a time saver, you would say. And I'm going to use it in the next problem just to kind of, again, save some time. So in this problem, we're told that the sine of an angle is 2/3, and that angle is located in the second quadrant. So what I'm going to do is I'm going to draw my second quadrant. I'm going to draw my angle, and I'm going to label what's given. I know my opposite side is 2, and I know my hypotenuse is 3. So just like before, Pythagorean Theorem, a squared plus b squared, so a squared plus 2 squared equals your hypotenuse squared. So in this case, a squared is going to be 5, so a is the square root of 5. No simplifying needed. But notice I'm going to the left. When you're dealing with quadrants, you have to be careful. Since I'm going to the left, this side is actually negative square root of 5 on it. And that's important because of finding our trig ratios. Now, sine of theta was given to me, 2/3. Cosine of theta I found by using the Pythagorean theorem, is I know my adjacent side is negative square root of 5 over my hypotenuse, which is 3. And tangent of theta is opposite 2 over negative square root of 5. Again, the negative goes to the top. But we have to rationalize this. So I multiply by square root of 5 over square root of 5. And what that's going to tell me is I know the tangent of theta is negative 2 square root of 5 over 5. So I have all my information I need to plug into my formulas for sine of 2 theta and cosine of 2 theta. And then tangent of 2 theta. So let's start with sine of 2 theta. Sine of 2 theta, it's a really straightforward formula. Twice the sine of theta times the cosine of theta. Nothing too complicated. So I'm just going to plug in everything from the right triangle. Twice the sine of theta, which is 2/3, times the cosine of theta, which was negative square root of 5 over 3. Again, you're just going to multiply your coefficients. So 2 times 2 times negative 1 is a negative 4. The radical 5 is all by itself. And at the bottom, 3 times 3 gives me 9. I think sine of 2 theta is probably one of the quickest ones to do with calculations. And we're going to use this to help us for, I would say, the tangent of 2 theta. So there's your sine. Now let's do cosine. And I'm going to do the same thing I did before. When we dealt with cosine before, what we did was kind of quickly went through which formula I would use, because there's 3 of them. Now in this case, the one I would use is, I'm going to use the one that deals primarily with sine, which that formula is 1 minus 2 sine squared of theta. Now I could use the one that's cosine squared of theta minus sine squared of theta like I did on the other problem, but if I look at my pre-trig ratios, I mean, sine's the easiest, 2/3. I mean, that's easy to square, it's easy to multiply. So I'm going to use that one. So I have 1 minus 2 times 2/3 squared. That's 1 minus 2 times 4/9, which is 1 minus 8/9. Let me just write down the left side here, cosine of 2 theta for each line. So when I finalize it, I get 1 minus 8/9, so I get the cosine of 2 theta is 1/9. And that is everything I need. Pretty straightforward for my calculations. So which formula do I use for cosine of 2 theta? Whichever one you want. But what I do is I think first, which fraction is the easiest one to use? And it's the sine of theta. So I'm going to choose the formula that deals with that one only. Or you can be assuming just uses the consistency. So cosine squared theta minus sine squared theta. I don't care. The last one, like I said, I'm going to do the little trick that if I know that tangent is sine over cosine, then tangent of 2 theta is sine 2 theta over cosine of 2 theta, because I already found all that information. So I have negative 4 square root of 5 over 9 over 1 over 9. And notice the denominators match. So really I have negative 4 square root of 5 over 1, which tells me the tangent of 2 theta is negative 4 square root of 5. Now that's my personal opinion. I think if I found sine and cosine of 2 theta already, I might as well use that to my advantage in order to save some time for the work. So those are your double angles. And that was a long 2 problems with it, going through the explanations. Hopefully it makes sense when we're dealing with it. The next set of problems deals with the half angle identity. These have their own set of formulas we'll deal with, and we'll kind of talk through it. The first one, you want to find the sine of 3 pi over 8. Now, in this case, let's convert everything to degrees. So 3 pi over 8 times 180 over pi. Now, if I do that, I get 67.5 degrees. In other words, this problem, I'm going to rewrite it, is really asking what is the sine of 67.5 degrees? Now, when you're dealing with the half angle theorem, really what it's saying is this is half of some other angle. So, and again, I'll just write it and show the steps for the first problem is half of an angle is 67.5. So to find out what that angle is, you would just double it. So if I double 67.5, I get that angle, alpha is 135 degrees. And so this is what I'm going to use in my formula for it. So the given information is half the angle we want. And so we're going to plug in what we're given. So if I want to know the sine of alpha over 2, which is 135 over 2, which again would be 67.5, I'm going to use my half angle formulas for sine. And let's write those down. Is I know, we'll fill in the information, the sine of my half angle is equal to plus or minus the square root of 1 minus cosine of that angle. So cosine of alpha over 2. Well, again, why plus or minus? And plus or minus is depending on which quadrant you're in. And we'll kind of look at that as we go through at the very end. We'll talk about it more. Let's just leave it there for the entire part of the problem, and we'll just deal with it as we get closer and closer to the end. So I know alpha is 135. So if I want the sine of 67.5 degrees, that's 135 divided by 2. Now, one of the reasons why we're using 135 is it's one of the angles that's on the unit circle. It's one of the angles in our trig chart for it. And so I have 1 minus the cosine of 135 over 2. So the sine of that angle So the sine, and I'll just start writing it as 67.5 degrees, is plus or minus. Now if I look at the right side, I have 1 minus the cosine of 135. Now if I go to my trig chart for this, I know the cosine of 135 is negative square root of 2 over 2. And that's all over 2. And so when you're dealing with your half angle formulas with this, it's going to be complicated because you have a lot of radicals. It's really important you kind of organize your work, and important you just kind of work your way left to right as you go through it. And so right now, here's where I am. And let's just deal with, kind of make it a little bit easier, just focus on the right side of the equal sign. Well, minus a negative is going to be a positive. So I know on the top, I have 1 plus square root of 2 over 2. On the bottom, I just have a 2. And still, I mean, it looks complicated. Again, I'm just going to start writing only the right-hand side so we can make it a little bit easier for us. Plus or minus. Now, if you notice, you have a numerator denominator. The denominator is not bad. This denominator is just 2. So I'm just going to leave that one alone. The one that kind of, I'd say, would freak you out is the one on the top. That one's still not bad because in order to combine these, you have to have a common denominator, which in this case, 1 is really 2 over 2. So the top here is going to be 2 plus square root of 2 over 2. And now I can keep on kind of simplifying. If you want to flip and multiply, you can flip and multiply on this. And just so you kind of see what you're going to get is you're going to end up with 2 plus square root of 2 over 4 inside that radical. Because if you flip this denominator, it's really 2 over 1. So when you flip it, the 2 really goes to the bottom, which 2 times 2 would give you that 4. So in this case, I have a 4 on the bottom, which now it's not bad. It's going to look complicated because you have a radical inside a radical, but when you have a radical, the fraction, you break it across the top, and you break it across the bottom. Well, the square root of 4 is 2. So that's it, except for, I said we'll deal with it at the end, that plus or minus. That plus or minus, that's the ending. That's the part you need to worry about, because my answer is not positive or negative. My answer is one of them. And how do I know which one is based off of what's the angle we're dealing with? The original angle we were dealing with was 67.5 degrees. And so that would be about right here. And if we label this, all students talk constantly, we can see that the angle is in the first quadrant where everything is positive. So that tells me the sine of 67.5 degrees is going to be a positive square root of 2 plus square root of 2 all over 2. And that's my answer. So how do I choose positive versus negative is based off of which quadrant, and this is important, it's the original angle. So which quadrant is the original angle in? So if you want to take care of that in the beginning, take care of that in the beginning, then you won't need to deal with this whole plus or minus the whole way down. You would just deal with one of them. If you don't wait to the very end like I did on this problem, you can. To kind of help you out in the next problem, we'll just go through and deal with it. Tangent of 22.5 degrees. Now this one's nicer because it's given to us already as a degree. So what the problem's saying is this 22.5 is half the angle we're looking for, which tells me I want to use 45 degrees in my formula. You have two options, and I'm going to write them down and kind of talk you through which one. Is you have, if you want to take the tangent of alpha over 2, it's either 1 minus cosine of alpha over the sine of alpha. Or the other formula is going to be sine of alpha over 1 plus cosine of alpha. Now, it doesn't matter which one you do. Going to give you the same work, going to give you the same information. I like to just kind of be smart. I know I need to figure out what's sine and what's cosine for both of them. What's sine and what's cosine. So if I look, and I'll write it down on the side to kind of show you my thought process on which tangent formula do I use, is I have here the sine of 45 degrees is square root of 2 over 2. The cosine of 45 degrees is the same, square root of 2 over 2 is an isosceles triangle. So which one do I use? Well, they're both the same, so they're both just as difficult. So I'm going to look at what's the most difficult part of the problem, and that's the denominator. Which of these denominators do I want to use square root of 2 over 2 in? Do I want to use it by itself and rationalize, or do I want to do 1 plus it and then rationalize? And sorry, but for me, I would rather use the first one because it's just one term in the bottom. So something tells me it's going to be complicated, but it's not going to be as hard, hopefully, as the other one. So I'm going to use the 1 minus cosine of alpha over sine of alpha. If you want to see the other one, it's online in my answer key. So again, I'm just going to kind of make my life easier. I'm just going to write down the right-hand side, 1 minus the cosine of 45 degrees over the sine of 45 degrees, which in this case becomes 1 minus square root of 2 over 2, all over sine of 45, which is square root of 2 over 2. Again, I mean, it looks complicated, and this is where you just have to kind of deal with it and work with fractions and radicals. But notice the top is going to be very similar to what we did in the previous problem. I need a common denominator there, and that would be 2 over 2. So in this case, I get 2 minus square root of 2 over 2, and in the bottom, I get square root of 2 over 2. So that's not bad. It makes pretty good sense what you're dealing with. Common denominator, the bottom stays the same. And notice, by the way, if I were to flip and multiply, this would cancel out with this because they're both in the bottom. So really, I have 2 minus square root of 2 over square root of 2. Now, no matter what, oh, sorry about that. No matter what, which formula you use, you're going to have to rationalize. Whether I use the other one or I use the one that I'm doing right now, I'm going to have to rationalize. So I use this one because rationalizing here is not as hard as the other one because I'd have to use a conjugate on the other one, and I frankly just don't want to do that. And so what I'm going to do is I'm going to distribute across the top. 2 times radical 2 is 2 square root of 2. Radical 2 times radical 2 just cancels, so I just get minus 2. On the bottom, same thing, radical 2 and 2 cancels. Well, all my coefficients are divisible by 2. So I can factor and cancel out a 2. So my final answer, the tangent of 22.5 degrees is 1 square root of 2, which is just square root of 2, minus 1 over 1, which we don't write. So then here is my answer. Tangent is the annoying one when it comes to half-angle theorem. But one way to make your life easier is to figure out which formula to use. So take a moment and analyze the sine and cosine values and figure out which formula is easier for those. There are some more videos on the portal from some other people who have posted half-angle ones if you want to take a look at them to help you out. Let's just deal with now finishing up the front page with questions 5 and 6 for it. So when we have question 5, we are asked to verify an identity. So this kind of deals with our kind of 5-2 concepts, but now we're dealing with angle theorems. So you have to pick a side, and I'm going to keep the left-hand side. It's not bad. It's pretty nice looking. It's sine and cosine. But look at the right-hand side. I can see the bottom, cosine x plus sine x. I'm going to leave that alone right now. The top, I'm going to change. This cosine of 2x, that is my double angle theorem for cosine. There's three formulas. Remember, there's three of them. It would be cosine squared of x minus sine squared of x. For your formulas for it, it's going to also be for us the ones that deal with 1 minus 2 sine squared of x. Or it could be the 2 cosine squared of x minus 1. So you have to figure out which formula do I want to use. Do I want to use the first one, the second one, or the third one? Well, then you have to look at the left-hand side. Which of these three kind of looks like the left-hand side? And the one that looks like the left-hand side to me, cosine of x minus sine of x, that'd be the top one. It'd be the cosine squared of x minus sine squared of x. That looks the most like the left side. And it's really helpful. And the reason why is you have to remember your trig ratios, those are just objects. So this right-hand side is really like a squared minus b squared, which we can tell is a difference of squares, a plus b, a minus b when factoring. And I can actually do that with the top, is I can perform my difference of squares. I can do cosine of x plus sine of x times cosine of x minus sine of x. Now the left-hand side stays the same, which by the way, cosine of x minus sine of x is on the left. And by doing difference of squares, notice I created it on the right, which is really good. And then the bottom here, cosine of x plus sine of x. And I'll put that denominator in a parentheses so we see it as an object. And it's going to make our job a little bit easier because notice there's a common factor in the top and the bottom is all multiplication, so they can cancel out. So cosine of x minus sine of x, what am I left with? Cosine of x minus sine of x looks like the left-hand side equals the right-hand side. Q, E, D. It has been demonstrated for the problem that those two are equal to each other. So that's number 5. We're trying to use our identities with our double and half angle theorems now like we did with 5-2. Sometimes you're going to have to think first on which formula you want to use, especially if you have cosine effects. Good news is number 6 is sine of 2x, which isn't bad because the sine of 2x is a very simple process for us. Now in this case, I'm going to work on both sides. I don't like cotangent of x because all the rest have sines on it. And so what I'm going to do is I'm going to change cotangent of x to cosine of x over sine of x. That makes me feel better. I'm also going to change this sine of 2x. The sine of 2x, we have a formula for. We know it's twice the sine of x times the cosine of x. And I'll touch the right-hand side at the end just to kind of see what happens. Well, if I take a look now, that's not bad because I have all multiplication going on, so a common factor in the top and bottom can cancel. So the left-hand side is a 2, and a cosine x times cosine x would be cosine squared of x. That's good. Now what with this right-hand side I left alone? Well, nothing's there yet that I can do. With that sine squared, I don't want a sine squared, I want a cosine squared, so I know I have to change that. Well, to change sine squared into cosine squared, I know at some point I'm going to have to do a Pythagorean identity. But I'm not going to do that yet. Because I noticed for this problem, there's a 2 and a 2. And I want a 2. So what I'm going to do is I'm going to use my GCF. I'm going to factor out a 2 from it. And that's going to give me a 1 minus sine squared of x. So now I have that 2 I'm looking for. I don't want to change it. I'm going to keep it as is. And that's perfect because now I have half the information I want. The other part I want is cosine squared of x. Well, take a look. 1 minus sine squared of x is that Pythagorean identity I was looking for. It is cosine squared of x. And lo and behold, the left-hand side equals the right-hand side, Q, E, D. So 5 and 6 dealt with going through and working with our double angle identities with verifying identities like we did in 5.2. 1 through 4 are the ones that dealt with the new concepts for us in 5.4, the double angle and the half angle identities. Between the two, between double angle and half angle, I think double angle is probably the easiest, particularly with this kind of shortcut for tangent to theta. The one that involves the most work and the ones that just tedious work in going through is going to be our half angle ones. So do some more practice with those. Look online at some of the extra videos that are there, and we'll go from there. Now, the next video in the series is going to look at the second page of it, which is problems 7 through 12. So to keep on looking at the review, watch those videos.